Hi children, this is your physical science facilitator SS from Commando Group of Schools. Welcome to the online classes. The students, in the last session we learned about pH scale and some applications of the pH scale. I think up to 2-3 key and why the living organisms are having narrow pH range. Okay, who introduced the pH scale? Sorensen. Yes. What is it by pH in the German language? Potence nothing but the power. Okay, right. So following the textbook, nice. Now let us see how that antacid tablets will work. Antacid tablets. For that I will explain you like this. Let us consider it may be your stomach. Assume this conical flask is your stomach. So in your stomach what happened? Continuously acid is going to be released, no? Gastric juice is released. So in your stomach gastric juice is released. So what is the purpose of that? It has to digest the food. It has to digest the food. So gradually acid. So now what is there in your stomach? Acid is there. If you should not take diet properly, what is the function of this acid? It has to digest the food. If food is not there, it has to digest. It has to digest. So what happened? This impact will be there on your stomach. So acidic nature will be increases. Acidic nature in your stomach is going to increases because acid is there in your stomach. So it has to be neutralized. What is there in your stomach? Acid. When the acid is going to be neutralized? By adding a base. For that I am going to take the antacid tablets. Antacid tablets. Directly we should not take the tablets, no? Along with water we will take. Along with water means dilution. So I am going to take water here. In this water, tablets, antacid tablets. Okay. I am going to take antacid pieces of the tablet. Antacid pieces of the tablets. Now they are going to be dissolved in it. So antacid tablet solution can be attained. Antacid solution. So what is there in your stomach now? Acid is there. To that acid what I am going to add? Antacid solution. Let us see what happened. First we should know what is this, whether it is an acid or not. No. For that I am going to add methyl orange. I am going to add some methyl orange to it. You may have doubt whether it is an acid or not. No. So I am going to add some methyl orange to it. Okay. So by following the textbook, that's very important. Following the textbook. So I am going to add methyl orange to this one. So what is the color? Red. Okay. Now red color is there in your stomach. Now I am going to add base. Let us see what happened after adding this tablet solution. See there what is happening to that particular color. Gradually, slowly it is going to be changing now. Okay, we will take some more concentration. Okay, slightly the concentration has reduced. The concentration has reduced. Okay, so like this in your stomach the neutralization is going to takes place. Okay, is it clear? So to reduce the acidic nature, we are going to take antacid. What is there in antacid? Milk of magnesia. Milk of magnesia is nothing but magnesium hydroxide that will be neutralized. So you can get relaxed from that particular thing. Okay now let us see the pH range on different colors on those things. What is pH for? What is meant by pH scale? The negative logarithm of H plus ion concentration. Of course, the negative logarithm of hydronium ion concentration. Why you are writing this one? Because there is no independent existence of H plus ions in aqueous solution. Let us consider it may be the pH scale. pH scale, the values are from 0 to 14. The values are from 0 to 14 with the different colors. Now let us see the range and of course the colors also. 0 to 2. 0 to 2, the color is deep red. Deep red is dark red color. 0 to 2, the range. The range of pH from 0 to 2 is dark red, means those are very strong acids. 3 means orange. 3 means orange. 4 is parrot green. 4 is about parrot green. 5th one is about apple green. What do you call that? Apple green. Light green. Apple green. Apple green means you know about raw apple. Okay, so in that color will be present at 5th one. Now if the pH value is 6, that is about light green. 7th one is green, and 8 to 9 is about dark green. Dark green. Now if you say about the 10th one is about bluish green. Bluish green. Okay, 11th one is blue. From here to here, 12 to 14 is about deep blue. So based on this color, if you are going to be advised to take a pH paper, and if you identify the color, based on this you can identify what is the nature of the particular thing. For example, if you want to test a soil, if you want to test the soil, then what you have to do? Have to get the soil of your land at different places. Okay, take some samples and make it as the solution. It's aqueous. When you dissolve in water, you may get the soil solution. That soil solution can be tested with pH paper. Test with pH paper. So, if the color is about, if the pH paper in your soil solution, means what you are taking first? Take a portable flask or maybe anything. With this soil, sample of the soil, and add water. Then what you will get? Solution. Soil solution can be added. Now this soil solution is going to test with the which one? Is pH paper. That can be tested with pH paper. If we test it, it may give as orange in color. That is considered as orange in color. Light orange color is given by this solution. From this, what you understood, orange is that means 3. pH value is 3 means acidic. Means the soil, means your soil is having acidic in nature. Acidic in nature is there, means they will suggest you what type of crop you have to be selected. If the crop is need excess of acid, you have to go for that. If you have to give any other one, because profitably any basic crop you have to be given, means at the time what you have to do, you have to neutralize your land. So the respective fertilizer can be suggested better. So by soil test, by the help of pH scale, we can identify the nature of the soil, whether it is acidic or basic or neutral. Based on the nature, we can identify what type of crop is suggestible for your land and what type of fertilizer is essential for your land. Have you understood? Okay, so like that we can test the soil. Okay, yesterday I told you about that pH scale, differentials of the pH scale, tooth decay, acid rains. Those are the applications of the differentiation methods of pH scale. Okay, let us see once again about this pH scale range of different colors. Whether 0 to 2 is deep red, 3 is orange, 4 is parrot green, the pH 1 is 5, apple green, 6 is lime green, 7 is green. So like that, colors are there. Now, with the help of this, we have to fill one table. All of you open the textbook, page number 32. In page number 32, one table is there. In the table, serial number, solution, and the color of the pH, and the pH value, and of course the nature as given in page number 32. Okay, just if you are not having the textbook, pause the video and get the textbook. You have to fill it. Already I told you, note table should be empty in our textbook because in the informative skills they must come. Okay, yes, let us come to the table. Okay, children, are ready with the textbook? In page number 32, you are having a table. In the table, first serial number, then solution, then about the color, and pH, and of course the nature. Now, the first one is about HCl. HCl. What is the color? 1 to 2 is given. Already I told you that 0 to 2 is deep red. So the color is deep red. So just beside of HCl what you have typed? Deep red, and pH value is 1 to 2. 1 to 2 means what is the nature? Acid. Acid. Okay, you write strong acid also, no problem. CH3COOH. Its color, if you see 3 to 4 is there, most probably you are going to take 3. 3 to 4 is there, but mostly you are going to take 3. 3 means what is the color? Orange. Orange. The pH, paper color is orange. What is the other name of pH indicator? Universal indicator. What do you call that? Universal indicator. Don't forget, litmus papers, blue litmus, red litmus, methyl orange, phenolphthalein, and olfactory indicators. Now pH, universal indicator. pH is universal indicator. Right. Now NH4Cl. NH4Cl. Here you have to understand one thing. NH4Cl can be attained from NH4CH and HCl. NH4OH and HCl. NH4OH is a weak base and HCl is a strong acid. But what is the color? Green. Green. Its pH value is approximately equal to 7 but slightly less than 7. Approximately 6.8, 6.97. So like that it is coming. So approximately equal to 7. And its nature is mild acidic in nature. Mild acidic in nature. Why mild acidic in nature? Because it can be attained from strong acid. If you see CH3COONA, it can be attained from CH3COOH and NaOH. CH3COOH is a weak acid, NaOH is a strong base. Okay, so here also the color is green. Color is green and pH value is approximately equal to 7. Approximately equal to 7. But here strong base we are adding. Strong base we are adding. So slightly it is basic, mild basic. 7.1, 7.2 like that. It is also approximately 7. It is also approximately 7. But NH4Cl is a mild acidic in nature. It is about mild basic in nature because strong base we are going to take to produce this solution. Right. Sodium bicarbonate. Sodium bicarbonate or sodium hydrogen carbonate. It's also green in color. Green in color, litmus paper green in color. Its pH value is 8.2. 8.2. Mild base and non-corrosive. Mild base and non-corrosive. Okay, don't forget two things I am going to specify here. Mild base and also non-corrosive. Right. Next, sodium carbonate. Sodium carbonate. And its color is blue. Its color is blue because the pH value is 10.5. Okay. So when it is 11 blue, that means bluish green. Bluish green. It is in between of 10 and 11. Most probably appear as a blue. It is also basic in nature. Basic in nature and it is also non-corrosive. These two carbonates, bicarbonate, sodium bicarbonate and sodium carbonate, both are non-corrosive. Non-corrosive. Okay, and this is basic in nature, this is mild basic in nature. Sodium bicarbonate. And common names are there, no? Okay, so what is common name? Na2CO3, washing soda, NaHCO3, baking soda, and NaOH, caustic soda. All three sodas are there here. And NaOH, deep blue. deep blue base. What is it? Strong base. Strong base because the pH value is 14. pH value is 14 and deep blue is color. Distilled water. Distilled water green in color. The pH indicator color is green and its value is 7. So neutral. It's a neutral solution. Distilled water. Right. Next, lemon juice. Red in color because it is approximately 2.2. Okay, nearby 2 point, maybe 2.3, 2.4 like that also it will be. It is acidic in nature. Then carrot juice, light green. Carrot juice is light green. It is also mild acidic in nature because the pH value is 5 to 6. Don't forget all these pH values. Suddenly half mark bit or maybe 1 mark question may come from this table. Coffee, once it's came, the nature of the coffee is, what is the nature of the coffee? Mild acidic. How can you say it is a mild acidic? Because pH value is 5 and litmus, pH color is green. Tomato juice, parrot green. Tomato juice, the pH indicator color is parrot green and its pH value is 4 acidic. Tap water, it's also going to be appear as green in color and the pH range is 6 to 8. 6 to 8. Then banana juice. This color is important for us. Banana juice. In banana juice, the pH indicator is about apple green. Apple green. It is also mild acidic in nature and the pH value is 5. Understood? Okay, so here color is important. Apple green. Next, aerated water. Aerated water means cool drinks. Aerated water means about cool drinks. In cool drinks, the pH color is about green and the range should be 6 to 8. But most of the aerated drinks, cool drinks, are not give the same pH range. Okay, they are going to be add some more ingredients. Okay, right, some pesticides are going to be present there. So the pH range will not be like this. So it is very mild acidic in nature. Very mild acidic in nature. How can you say it is a mild acidic in nature? Because what is there in the cool drinks? Carbon dioxide gas is there now. CO2 is acidic in nature. So that slightly acidic in nature. Don't forget the range may be 6 to 8. The range is maybe 6 to 8. But aerated water is acidic in nature. Coffee, aerated water and sodium bicarbonate. Okay, and lemon juice. These are repeated bits. And saliva. It is a controversial bit. Saliva before dietary, after dietary, its pH value is given, different values are given. Okay, based on our syllabus, it before bit 5.5, 6.3 and after bit 5.8, 6.9 given. But in the CBSE syllabus, they have given before that 7.4, after that 5.8 like this. So these two are controversial. And blood pH value is 7.3 to 7.5, mild base or neutral. Mild base or neutral and pH indicator is green. Don't forget the blood pH range. And urine, light green. It's a mild acidic in nature, 4.5 to 7.5 the range. And saline water also approximately 7. Its color also green. That is the reason why the saline is directly inserted into the nerves. What is there in the nerves? Blood. If the rate, if more difference is there in the pH range, suddenly metabolic system is going to be differentiated. Some problems are going to be raised in metabolic system. Already I told you, we are having all the living organisms having narrow pH range. So that is about 7 and 7.2. So directly it can be linked with blood nerves. Nothing is going to happen because they are having the same pH range. Okay. So once you see the values, okay, complete the table which is present in your textbook, and here one thing is not given, that is about the battery acid. Battery acid is not given here. Battery acid is pH value is 0. Note that one also. Totally in your textbook 17 is there, 17, but I am going to give 21. Okay, 17 and 4 more. Up to saliva is there in your textbook. Add blood, urine, saline water and battery. Okay, battery acid. Battery acid pH is 0. Battery acid pH is 0. And that one also. So totally 21 will be there. Okay? Understood? So I think if I complete, if I completed the table, right, let us go for that. our topic, regular topic. Okay, children. Now, already we learned what is pH scale and what is pH indicator. What is the other name of pH paper now? Universal indicator. So, with the help of this pH, we are identifying, we are using this pH in yes, tooth decay, acid rain. Next, very important one nowadays, soil test, and narrow range of living organisms, all the things we learned, and one table also. In that table, different solutions and their pH values. In that, few are important. Right. Now, self-defense. Some acids and maybe the bases which are present in some living organisms, they are going to be used for the self-defense. Self-defense. You know about the redax. Okay, let's check this. Redax and one more is the honeybees. Honeybees, they will release one string in our body when they bite us. No, one string. In that string, one acid is present. What we call that formic acid. Okay, acid. Generally, the functional group of acid is about COOH. COOH is about acid. Form means hydrogen will be there. Hydrogen. So formic acid. Similarly, if you see CHO means aldehyde. If you write H, formaldehyde. So like that, along with these functional groups based on this position of hydrogen, we can name them. COOH is acid. Before that, hydrogen. So formic acid. Where the formic acid is going to present here? Redax and honeybees. For example, redax. When the redax also by is immediately what happened? The place where that has been, that ailment we call it, that ailment has been bulges. Because they injected the formic acid in your body. Formic acid. To neutralize this, what is this acid? No? When the acid is going to be neutralized? Base. When we have the base. For that purpose, to neutralize this one, or to get relaxation, or get relief, to get relief from the pain which has been attained by this honeybee bite or maybe redant bite, on this ailment where the formic acid has been injected, then we have to apply NaHCO2, sodium bicarbonate. It's about mild basic in nature. No? So because of this mild basic in nature, when you apply on the surface of the particular thing where the ailment is going to be affected, then we get relief. Okay, because of applying this mild base. And not only this redax and honeybee, one more is the nettle plant. You know about the nettle plants. Okay, these nettle plants are also having the nature to release that formic acid. Commonly called Durada. Okay, so which will give that itching sensation. That is the nettle plant. Okay, that is also having self-defense. The way to release the formic acid. Okay, now understood? Sometimes this formic acid is also called as ethanoic acid. Okay, so it's about the self-defense. Now, based on this pH, some applicative questions are going to be given. We will ask learn that one also. Have understood? In the self-defense, we are having three things. Of course, duck plants also there. Duck plants. Okay, so like that, duck plants, nettle plants, redax, honeybees, those are having some acids for self-defense, for the purpose of self-defense. Right. And one question is given like this. Already I told you what happened when the milk converts into curd. What happened when milk converts into curd? pH value decreases. Means acidic nature is increases. Now, one question is given like this. A milkman is added some sodium bicarbonate. Is added sodium bicarbonate to the milk. Okay, so milk is there. To this milk is being added NaHCO3, sodium bicarbonate. Then what happens? Right? So after adding sodium bicarbonate to the milk, what happened to this pH value? Any guess? Milk. What is the acid present in milk? Lactic acid. To that acid, what we added? Sodium bicarbonate. What is the nature of sodium bicarbonate? Already I told you that its pH value is about 8.2. 8.2 means mild, basic in nature. So you are adding base to the acid. So what happened to this acidic nature? Certainly will reduce. So the acidic nature of the milk is reduces, so the pH value will increases. Don't forget, sodium bicarbonate is added. Sodium bicarbonate is added to the milk by a milkman. Why? What is the necessity of adding this one? What is the nature of this one? Acidic. Yes, sir. So, to enhance the lifespan, of the milk, they will add sodium bicarbonate. They will add sodium bicarbonate. Not only the milk, they may add for curd also. Okay, so by adding of this one, pH value, what happened? The acidic nature will decrease. Acidic nature decrease. Why? We are adding base now. So acidic nature decreases. Acidic nature decreases means pH value increases. So gradually when you are going from left to right, the pH scale from 0 to 14, when you are going from left to right, gradually acidic nature decreasing and will get neutral, from there basic nature increasing. So acidic nature from left to right decreasing. Similarly, from right to left, basic nature decreases. Okay? Right. So, we forget about this here. Acidic nature decreases by adding of this. So, pH value will increase. pH value will increase. Now, different salts. That's the topic. Next topic is about different salts. Okay. So, before going to that, our table is given. Tomorrow we will see the table. Means by the next class we will see the table. Now we will see different salts. Generally we call as the common salts. Before, means in some olden days, common salt means mostly they believe that NaCl, sodium chloride, common salt means. No. Table salt is NaCl. Table salt is NaCl. Common salts means so many common salts are there. So many common salts. NaCl is a common salt. Na2CO3 is a common salt. NaHCO3 is a common salt. CaOCl2 is a common salt. Okay, so like that. Next, CaSO4 half H2O. Mostly it may not considered as the common salt, but it is there in some books as a common salt. Right. So commonly using salts are common salts. Among these, different things will be there. NaCl is about table salt. It is about table salt. Sodium carbonate, you know, washing soda. Sodium bicarbonate, baking soda. CaOCl2, calcium oxychloride is called bleaching powder. Nowadays it's very much useful because it has been affected by corona. Right. So antigens, it will be used as the antigen because the presence of chlorine. Chlorine is a poison agent one, so you kill the germs. That is the reason. In some areas, the people who wanted to enter into the drainages, sometimes they want to clean the drainage. At that time, they have to go into the drainage. At that purpose, what they will do, they will take NaCl and apply on their bodies. Because NaCl is an antigen, it will kill the germs because the presence of chlorine. Of course, they will take bleaching powder also, but bleaching calcium is also there, calcium oxide, which may affect the body also. For that purpose, they are going to use NaCl when they enter into the drains, right? Antigens. And it's about CaSO4 half H2O. Calcium sulfate of heavy hydride. Heavy means half. Heavy means half. HO2 means water hydride. Calcium sulfate of heavy hydride. All these are considered as common salts. Okay, let us see how we can identify, how we can get these common salts and their uses also. Understood? Okay, don't consider common salt means NaCl. Okay, don't consider table salt means NaCl. Common salt means all these things will come as the common salts. Now, the first one is about NaCl, sodium chloride. Right. The sodium chloride salt can be obtained most probably from seas and oceans. Seas and oceans. Because so many minerals are dissolved, because water is a universal solvent now. So it can dissolve so many minerals and salts in it. Among that, the most superior one is about sodium chloride. As a crop, they are going to be enrich this sodium chloride. They are going to attain this sodium chloride. That this seawater and seawater, maybe the ocean water can be separated and it's to the fields of evaporation, we will call that. Then what happened? Water molecules are going to be evaporated and sodium chloride will be as the flakes. But there may be some chances of impurities. When impurities are going to present, the NaCl may not be white in color. Okay, at that time, that is called as rock salt. What do you call that? Rock salt. Okay, so the rock salt is about, commonly the color of that particular rock salt is about brown. Commonly, its color is table salt color. Table salt color is white. But when some impurities are there in it, when impurities are there, it will appear as brown. At that time, what we call this one? Rock salt. Rock salt. Okay, so the color of rock salt is about brown. Then what is the use of this NaCl? Already I told you NaCl can be used as the antigens. Okay, it can be used as the antigen solutions and table salt mostly used in cooking purpose. No? So then it will enhance the taste of the food. It will enhance the taste of the food and also increase preservative time. The preservative time will be increases and it will give good taste to the food. Enhance the taste of the food. Okay, so three uses are there. First one is about antigens, antibacterial solution. And second one is about it will enhance the taste of the food. And third one is it will expand the period, means preservative time of the food. Okay, so that's about sodium chloride. And few more salts are there. Those salts and their uses and one activity, copper sulfate activity is there. In the coming class, we might be complete that one, and applicative questions also are going to be complete. And don't forget one thing, follow the textbook, underline the important concepts, and you have to generate different types of questions. Okay, have a good day.